And friends, let me show you something. So this is an real number derivative, and I'm showing you another part in which this is an another part of conformal mapping. So as I have told you, let me create and show you that in here each curve traces another curve. But in here it is so simple that for a point you just go up and you have another point in y. That's it, nothing more very complex. And somebody has been asking me, why supposedly there is a tangent to a parabola, why not an parabola to a parabola, or an circle to a parabola, or an star to one parabola, or any kind of f of x curve which is very tangent to parabola. And somebody has been asking me why your channel name is Bola Calculator. Tell you the reason in this video. Okay, this is a complex number kind of thing. I have given a lot of lectures on that, and if you want you can go and check my older videos. So let's see. So in here, sorry, in here it is, in here, over here, what you are seeing in here, no, in this graph, when a point just approaches from a point from right side or left side, it has a tangent at the center. Okay, so what is the meaning in the terms of an complex number? So you have a point here, but the point over here will be mapped to some other point over here. Okay, so the when you trace a curve like this, the curve changes to some other curve like this. So what is the deal over here? When I will just show you an action of a line. When I'm just drawing a line over here, it turns into a very bizarre curve. Okay, sir, then what is the point that this is just turning into a some other bizarre curve? So what you're telling is, can we track parabola instead of a tangent? So I have made some of the arrangement in my videos to show you that. So here is something. So in here what we are going to do is we are going to animate it. Okay, and as you can see from here, you can see that an tangent of an parabola is being created. As you can see, a parabola is tangent to one curve. As you can see here, the parabola is tangent to one curve. This is created by conformal mapping. Okay, and I will show you the notebook also how I created it. So this is the curve. Okay, x plus z squared, it is supposed to be z squared, and you suppose you substitute x plus percentage iy. Percentage iy is a maximum index. It has nothing to do with the imaginary symbol which is shown over there. So it is just an imaginary number to tell. Okay, so for the maximum index we use percentage. You substitute for x the h, the limit uh, tending value. Okay, and for y you substitute a normal polynomial, and you get an polynomial of this form, and you just take the imaginary and real part, real part, and you just plot it over here, and you have an parabola tangent to another parabola. So what is the point over here? So I will tell you, and uh, complex derivative is not like a real number derivative. When you just approach here, it just approaches towards another point through a point. But actually what happens in a complex derivative is, when you just put a 2 point over here, it just transform into some other 2 point over here. So when you track a curve in here, it just can be here, but it will transform into some other curve like this or this or this. So when you just draw a tangent here, the tangent may transform into some other tangent over here. So the 2 points, it can go like this or go like that. So this is the kind of thing what happened over here. So I will give you all the formulas and show you all the formulas. So let me show you the first formula. This is just a polynomial, and these are the formulas that I can show you so far now. Okay, these are the formulas. You just take a good look at it, and in custom function you just put like this. So when you just animate, when I'm just animating and showing you, so a complex derivative is not a very difficult task to imagine. Okay, when you just go from here, it just takes, as you can see, it is just taking a tangent to that parabola. Okay, it is just taking a tangent to that parabola at some distance. Only for this z squared curve, when you just substitute those things. Okay, so much of my videos have been dealing with this so-called. So I am telling you again, when you just point over here, it just transform into some other point over here, and you just draw a line or you just draw a curve. The line is transformed into a curve, or this curve is also transformed into some kind of curvilinear thing. But when you just draw a circle over here, you just draw a circle over here, it is just a circle. But when you just draw that circle big, it transforms into some other bizarre curve. So watching, so this the theory is so simple. So when the it takes numerous points in an imaginary plane. Okay, it takes numerous points in an imaginary plane. It travels in this way or this way or this way, but the tangent can approach to another point in multiple paths. So this is how you think of complex derivative when substituting this. So this is what I was coming to tell. So thank you. I will give you all the resources what I have used. So you have to have a very good imaginary power in mathematics to think a lot in this complex numbers and complex derivative. Thank you.